everybody, my name is Isaac Berry for Berry Science Lab. Today on Math for Children, we're going to be doing lesson 5.3, functions. So, functions were basically invented by Sir Isaac Newton and Gottfried Leibniz. Newton was an English mathematician and Gottfried Leibniz was a German mathematician. And both of them we're going to give credit to for basically inventing functions. Because Sir Isaac Newton considered the term when he was inventing calculus, and Gottfried Leibniz was the first one to actually use the word function with its current meaning. So, let's talk about functions. Functions are basically a set of points that follow a certain rule. So, for example, let's say we have the coordinate plane right here, 1, 2, 3, -1, -2, -3, and similarly. Okay, so functions are basically a set of points that follow a certain set of rules. So, for example, the function y equals x would have, let me give you a reminder, would have all points having their y equal to their x. So, for example, a point on the function y equals x would be 2, 2, which would have the same x as y. X and y are the same. They're both 2. Another point would be -1, -1. And by the way, obviously there are decimals on this whole number line thing too. But I just not bothering to draw them. So this would be -1, -1. X and y are the same. And of course, there are many more points that follow this. And when we draw them, we get what we call a graph. So for example, we draw 0, 0, which is the origin, 1, 1, -2, -2, and -3, -3. And now we've created a graph. Well, not literally. We need a bunch more points. But for example, this point obeys the same rules. It's 0.5, 0.5. So we can draw a line containing all the points that obey this rule. And it would look something like this. As you can see, it's actually a perfectly diagonal line, but this is just the simplest of functions. So that's basically what a function is. Now, how can we express it? Now, some people, when they're graphing functions, might want to make a little plan out of it first. So, this basically shows you the x of a function and the corresponding y. So basically, at some x value, what the y value of the function is. So, what we can do here is, for example, so this just shows you, let's do it for y equals x. At -3, y would be -3. And you can expect this because y is always going to be equal to x. So if I have, for example, 175, then for x, then since y is equal to x, I already know just instantaneously y is also going to have to be 175. So anything will follow this pattern. If x is pi, y is pi. So now, what about a different, more complicated function? Well, let me show you something different. Let's move to a different coordinate plane. This one is a little too small. 1, 2, 3, 4. 1, 2, 3, 4. -1, -2, -3, -4. -1, -2, -3, -4. Okay, all right. So let's try graphing something like 2x. So something like 2x would be a little spicy because this would be 0, 0, right? But now, let's think of one point that obeys y equals 2x. That basically means their y coordinate has to be twice their x coordinate. One point that obeys this is this point, 1, 2. Its y coordinate is 2 times its x coordinate, because 2 is twice 1. Another point that obeys the same thing would be, for example, 2, 4, because its y coordinate is twice its x coordinate. 4 is 2 times 2. And similarly, we can obviously do the same thing in the negatives. Minus 2 is 2 times minus 1. Minus 4 is 2 times minus 2. So now you can already see it's just going to be a little steeper of a line, but we can draw out the entire thing. And that's how it's going to look. And similarly, if I were to draw like a table of x at one point and y at one point, I'd know that if x is something, y would just be 2 times that something. If x was something, y would just be 2 times that something. If x was something, y would just be 2 times that something. And that just repeats on and on. So there were some more complicated graphs, like for example, you remember how I showed you exponents? Well, you can do that for functions as well. Y equals, let's say, 1/2 x squared. I mean, that one's a very complicated function, because something that would obey that would look like, for example, 2, 2, because this is equal to 1/2 times 2 squared. So it would look like a really weird, I don't know, a sort of function. So it would look a little bit like this, by the way, for any of those curious minds who are thinking about it. So that's functions. Now, how can we can actually plug in numbers into functions. So you might see functions not just being called y, but also f of x. Don't worry though, this thing means the same thing. For example, now what if we plug in something to that x? For example, f of 2 is basically asking what is y at x equals 2. See, we just substitute in the number that x is into f of x. So f of 2 would be, for example, in that one weird function, 1/2 x squared, f of 2 would be 1/2 2 squared. You would just plug in x equals 2. Now this might seem confusing, so watch the video a few times if you don't understand this at first. And if we plug in any x, like for example, f of 8 is going to ask what is this function at the value of x equals 8. 1/2 8 squared, 1/2 64, 32. So as you can see, this function gets big a little quickly. But that's the thing. So that's how functions work. They're basically a collection of points that fall